How does a model draw the line between cat and dog, spam and not spam? Quite literally with a line, or in higher dimensions, a plane or a hyperplane. This single geometric idea is the backbone of classification. Let's draw it. Start in 2 dimensions. A straight line splits the plane into 2 halves. Points on one side are class A, points on the other are class B. To classify a new point, you simply ask, which side of the line are you on? That is the entire idea of a linear classifier in one picture. How do we describe that line with math? With a weight vector W and a bias B. The rule is W.x plus B. If the result is positive, you are on one side, if negative, the other, and exactly 0 means you are right on the boundary. The dot product deciding class. The weight vector W has a beautiful geometric role. It points perpendicular to the boundary, straight across it. So W is the direction of steepest change from one class to the other. Tilt W and the boundary rotates, change B and the boundary slides, together they place the line anywhere you like. Now scale up. In 3 dimensions, the boundary is a flat plane slicing through space. In 1,000 dimensions, where real data lives, it is called a hyperplane. We cannot picture it, but the equation is unchanged, W.x plus B. The same one line of math separates data in any number of dimensions. Which boundary is best? Often, many lines separate the data perfectly. The support vector machine picks the one with the widest margin, the largest gap to the nearest points on either side. A wide margin means a confident, robust decision. Maximizing that gap is a classic geometry problem solved with the tools we have built. And every neuron does exactly this. A neuron computes W.x plus B, the equation of a hyperplane, and then decides which side you fall on. Stack many of them, and the straight boundaries bend and combine into curved, complex regions. Deep learning is layers of hyperplanes folded into shape. So, hyperplanes. A boundary that splits space into classes, described by W.x plus B. The weight vector points across it, the bias slides it. From one line to 1,000-dimensional hyperplane, the math never changes. That closes our geometry. Next, we turn to circles and waves. Chapter 11, the unit circle.